Hello everybody. In this video we are going to focus on a scalar multiplication of matrices. Okay, let's get to it. In matrix algebra, a real number is often called a scalar. To multiply a matrix by a scalar, we multiply each entry in the matrix by the scalar, so it means that we are going to multiply all elements by the scalar. This operation is called a scalar multiplication. You're gonna see here. C is our scalar identity, and the matrix A, B, and D is given. To multiply matrix by a scalar, we will multiply C, all of the elements. So C times A, C times B, C times B, and C times D. We're gonna get this. Okay. So we're gonna go over some examples relating to that. The matrix is given, A and B, you're gonna see, and we have to perform the matrix operations. Okay. For the first one, we will get a 3A, means that we will multiply 3 by all of the elements of the matrix. Okay, so, and the 3 times the matrix elements 1, 2, 4 is negative 3, 0, negative 1, 2, 1, and 2. Okay. So we have to multiply a 3 by each entry of the matrix. So it's going to be a 3 times 1 is 3. 3 times 2 is a 6. 3 times 4 is 12. Negative 3 times 3, which is negative 9. 0, negative 3, 6, 3, and 6. Okay. And for the second example, we have to find a negative b, which means we will multiply matrix B by negative 1. So the scalar value for us is a negative 1 times the matrix B is 2, 0, 0, 1, negative 4, and 3, negative 1, 3, and 2. So we have to take the opposite sign of each entries here. So it's going to be negative 2, 0, 0, negative 1, 4, negative 3, 1, negative 3, and negative 2. Okay. For the next example, we're going to go ahead and perform this operation, find the matrix that corresponds to 3A minus B. Feel free to try that. So 3A was 3, 6, 12, negative 9, 0, negative 3, 6, 3, and 6. And the matrix B was negative 2, 0, 0, negative 1, 4, negative 3, 1, negative 3, and negative 2. Okay. So we are going to subtract A11 from here with A11. So a 3 minus minus 2, right? So actually, we're going to have, for this example, is a positive because we got the negative b. This is the negative b. Okay. So directly 3 minus negative 2, which is 1, 6 minus 0 is a 6, is a 12. Negative 9 plus negative 1 is going to be negative 10. 4 and negative 6. For the last row we have 7, 0, and 4. Okay. We got it. In this section, we are going to find the value of x and y. The matrices multiplied by a scalar 2, it gives us 0, 18, 6, and 14. Okay. So we will multiply 2 by 3, 2 by 2x, 2 by 6, and 2 by 4. And we will have 6, 4x, 12, and 8, right? And plus 2 by negative 3, negative 6, 2 by 5, 10 is a negative 6y, and 6 is equal to 0, 18, 6, and 14. Okay. And to get the value of x, we are going to focus A12. And from here is also A12, which is 4x plus 10. And the corresponding entry is going to be 18. For x is equal to 8, which happens to be 2, right? To find the value of y, we are going to focus the second row and the first column. So it's going to be the 2 to right, the second row and the second column. And here we have a 6. It's given 14, so it's better to take 12 and negative 6y, which is the second row and the first column, which is 2, 1. So it will be 12 minus 6y is equal to 6. So from here we'll get for the value of y is 1. Okay. We have a check yourself 8. I want you to take it over. In this section, we're going to talk about matrix multiplication. So first, once we solve two matrices, actually first we are going to focus on their dimensions. The matrix m times n and the second matrix is p times q. You're going to see the dimensions of the matrices. So here is the first rule. To get matrix is exist, n must be is equal to p, and after that we can multiply the matrices. But we have to decide what is the dimension of the matrix. So here is, you're gonna see, we have an example. The matrix A and matrix B, you're gonna see here the all elements 1, 3, 2, and 1, 4, 2. First we have to define the dimension of the matrix. So what is the dimension of the first matrix? So it's going to be, we have just 1 row and 3 columns. So it's going to be 1 times 3. And for the second matrix, we have 3 rows and 1 column. Okay, so to find the answer, we have to provide something here. What is that? It was n is equal to p. So 3 is equal to 3. You're going to see that. So the automatically, what is the dimension of the result? It's going to be 1 and 1. Yeah. So the result will be 1 and 1. We got the dimension. And after that, how can multiply the entries with each other? So here is first, we are going to multiply all elements of the first row by all elements of the first column. So 1 times 1 is 1, 3 times 4 is 12, and 2 times 2 is going to be 4. When we add all these numbers at the end, I will have 17. Okay. Let's take a look at slightly different problems here. The matrix A and matrix B is given, and we are going to find their products. Okay, to get A times B, the matrix A is the all entries 2, 1, negative 2, 3, 1, and 5. And the matrix is a B. It's going to be 1, negative 1, 5, negative 2, 0, 6, 3, 2, and 4, right? Okay. So the dimension of the first matrix, which is A, we have 2 rows and 3 columns. So it's going to be 2 times 3, and the second one is 3 times 3. To multiply 2 times 3 and 3 times 3, we have to provide it first. 3 is equal to 3. So when we multiply A times B, the result of the matrix will have 2 times 3 dimension. Okay. So it means that first we are going to multiply first row by first column. Okay, so 2 times 1, right? 2 times 1 is 2, and after that 1 times negative 2 and negative 2 times 3. Okay, let me arrange it. Okay, so here is we will multiply 2 by 1, 1 by negative 2, and negative 2 by 3, when we add them, we are going to have is -6. Okay. To get first row and the second column of the matrix, we are going to have the second row and the first column, because this is A21 entry, right? No, A12. Yeah, sorry. It's going to be A12 entry, which means the first row and the second column. So it means that to get here the value, we are going to multiply first row by second column, which is 2 by -2 and -1, 0, and 2. Okay. So it means that we will multiply 2 by -1, 1 by 0, and -2 by 2. It's going to be -6. Okay. For the next entry, we will take the first row and the third column. So 2, 1, 2, and 5, 6, 4. Yeah. The first row and the third column. So 2 times 5, 1 times 6, -2, and 4. When we rearrange it, we will get for first row and the third column is 8. And after that, we will continue with the second row and the first column, which is 3, 1, 5, and 1, -2 by 3. So when we multiply 3 by 1, 1 by -2, 5 by 3, we have 16. And for the second row and the second column, we are going to have 3 by -1, 1 by 0, and 5 by 2, which is 7. For the next entry, we will have 4 to 1, which is 3 times 5, 1 times 6, and 5 times 4. Okay. And for the last row, we are going to have, what do you think about the last row? For now, what is the dimension of the matrix? There are 2 rows and 3 columns, so we already got this. Yeah. So the answer for A times B will be -6, -6, 8, 16, 7, and 41. To find B times A with the same path, we are going to have a different entries, which is, I would like to let you solve it actually. At the end, you're going to see that B times A is not equal to A times B. Yeah. Okay. So for the basic arithmetic operations, we know that A times B is equal to B times A, but for the matrices, it's very little different. Check yourself, 8. Okay, so here is the matrices A and B, and we're going to prove that A times B is not equal to B times A. Okay, so I'm going to show you multiplication of the matrices with the details. So the A times B, 0, 3, -2, and 6 times -1, 7, 2, and 4. We are going to start with the first row and the first column, so which is 0 times -1 plus 3 times 2. And for the first row and the second column, we will multiply first row by second column, which is 0, 3, and 7, 4. So it's going to be 0 times 7 plus 3 times 4. For the next entry is going to be the second row and the first column, which is -2 times -1 and plus 6 times 2. For the last element of A times B matrix, it's going to be -2 times 7 plus 6 times 4. Okay, it's pretty easy. Yeah, it's pretty easy. So the rest of the way, it's going to be the basic arithmetic operations. So 6, 12, and 14 and 10. Okay. This is A times B. And let me show you right now B times A. Using the definition of the product of two matrices, we get for B times A, let me write directly. So negative 14 as 39, and negative 8 and 30. Also, you can prove it. As you see here, A times B is not equal to B times A. So we say, in conclusion, matrix multiplication is not in general commutative. A times B is not equal to B times A. In this section, we are going to multiply matrix X by matrix Y, Y and X squared and Y squared. Okay. When we multiply X, Y, and YX, you're gonna see the results for the multiplication. We have for X times Y 0, 2, negative 2, and 4. For Y times X, you're gonna see here 1, negative 1, 1, and 3. They're 100% different from each other. So XY is not equal to YX. To get X squared, of course, we will multiply matrix by itself. 2, 1, 0, negative 1, and 2, 0, 1, negative 1. So 2 times 2 and 0 times 1, 2 times 0 and 0 times negative 1, 1 times 2 and negative 1, 1. And for the last elements, we will multiply 1 by 0 and negative 1 by negative 1. So you're going to see all entries of X squared, which is for 0, 1, and 0, 1 and 1, sorry. And for Y squared, we are going to have 2, negative 3, negative 6, and 11. Okay. So for the identity matrix, remember the diagonals are 1, except the other entries the other entries are going to be 0 and 0. This is our identity matrix. Remember this. If we're going to take any power of identity matrix, still the answer remains identity matrix. Okay. So it's a very good option for us. Check yourself 9. Okay, here is we are going to find the matrix A is given 3, 2, 0, negative 3. By giving this matrix, we will find A to the power of is really slightly very large power for us, 1986. Okay. So here is all we need to do is first calculate A squared. Yeah. So which is A times A. So when we multiply A by A, we will have 9, 0, 0, and 9. So we can simply that by using a scalar multiplication. So it's going to be 9 times 1, 0, 0, and 1, right? Yes. 1, 0, 0, 1 is identity matrix, so it's going to be 9 times I. So automatically, to get A to the power of 1986, we use a perfect square of A, which is A squared to the power of 993. And substituting A squared is equal to 9I gives us 9I to the power of 993, which is 9 to the power of 993 times I to the power of 993. Okay. Since I to the power of 993, it's going to be I, because remember from the previous session, I to the power of n is still I, which is identity matrix. And we get 9 to the power of 993 times I, which is 9 to the power of 993, 0, 0, and 9 to the power of 993. Okay, because the I is identity matrix, we are going to substitute for I as 1, 0, 0, and 1, and after that, the rest of the multiplication. You have already learned this. How can multiply matrix by a scalar? So, as a result, though, the answer is 9 to the power of 993, 0, and 0, 9 to the power of 993. For the next lesson, we are going to have the transpose of a matrix. So I would like to end up my lesson here. Have a nice day. Thank you.